How to solve a right triangle using cosine formula. As shown in the right triangle, let AB is the hypotenuse side while AC is the adjacent side of angle theta. Thus, the formula is cosine of an angle is equal to adjacent side divided by hypotenuse side. To solve the angle, the value of angle theta will be equal to inverse cosine of adjacent side divided by hypotenuse side. To find the value of the adjacent side, multiply the value of the hypotenuse by cosine of an angle. Thus, adjacent side AC will be equal to hypotenuse AB times cosine theta. To find the value of the hypotenuse, simply divide the adjacent side by the cosine of an angle. Thus, hypotenuse AB is then equal to adjacent side AC divided by cosine theta. Let us now have some sample word problems. A cone with a radius of 2 feet and has an unknown distance of its base from the base of a cube. Find the distance of the base of the cube from the base of the cone if the line of sight to the vertex of the cone has an angle of 70 degrees with respect to the floor. Let us now illustrate as stated in the word problem. Let DC is the radius of the cone equal to 2 feet while AB is the line of sight from the base of the cube to the vertex of the cone with a distance of 15 feet and forms an angle of 70 degrees from the floor. Since the unknown distance AD is from the base of the cube to the base of the cone, the equation will be cosine 70 degrees is equal to AD plus 2 feet all divided by 15 feet. To eliminate the value of 15 feet at the right side of the equation, multiply both sides of the equation by 15 feet. The equation will now become cosine 70 degrees multiplied by 15 feet is equal to AD plus 2 feet. To eliminate the value of 2 feet at the right side of the equation, subtract 2 feet from both sides. Rearranging the equation from left to right, unknown AD is now equal to cosine 70 degrees times 15 feet minus 2 feet. Using a scientific calculator, cosine of angle 70 degrees is equal to 0.342. Thus, AD is equal to 0.342 times 15 feet minus 2 feet. Therefore, the distance of the base of the cube from the base of the cone is equal to 3.13 feet. In our next example, a child is standing 10 feet from the house. If the line of sight from the feet of the child has an 80 degrees angle of elevation to the ridge of the roof where the bird is located, find the diagonal distance that the bird will fly downward to the feet of the child. Let us now draw as stated in the word problem. Let AC is the distance of the child from the house which is equal to 10 feet. The angle of elevation from the feet of the child to the ridge of the house where the bird is located is 80 degrees. Since the unknown diagonal distance from the ridge of the house to the feet of the child is AB, the equation is cosine 80 degrees is equal to 10 feet divided by AB. To solve the diagonal distance AB, simply divide 10 feet by cosine 80 degrees. Therefore, the diagonal distance that the bird will fly downward to the feet of the child is 57.6 feet. In our last sample word problem, a diagonal distance from the bicycle to the light pole on the hospital roof deck is 85 feet. Find the distance of the bicycle from the hospital if the line of sight from its wheel to the light pole on the hospital roof deck has an angle of elevation of 75 degrees. Let us again illustrate as stated in the word problem. Let AB is the diagonal distance from the bicycle wheel to the light pole on the hospital roof deck. Thus, AB is equal to 85 feet. Since the angle of elevation is 75 degrees and the unknown distance of the bicycle from the hospital is AC, the equation will be cosine 75 degrees is equal to AC divided by 85 feet. To find the distance from the hospital to the bicycle, multiply 85 feet to cosine 75 degrees. Thus, the equation is now AC is equal to 85 feet times cosine 75 degrees. Therefore, the distance from the hospital to the bicycle is equal to 22 feet.